What is thermodynamics? Thermodynamics is the science of energy transfer and the effect of the transfer on the physical properties of substances. It is based upon the observations of common experiences which have been formulated into laws. The applications of thermodynamic laws are found in all fields, including but not limited to power plant, internal combustion engines, refrigerators, air conditioners, and fuel cells. All of these devices make use of heat to achieve useful work and vice versa. A thermodynamic system is defined as a region of space upon which attention is focused. The system is separated from the surroundings by a boundary which classifies the system into: first, closed system, where only energy transfer takes place; second, open system, where both energy and mass transfer takes place; third, isolated system, where no transfer takes place. Most thermodynamic systems are open systems. By analyzing such systems, attention is focused on a certain volume within the system known as the control volume. The surface bounding this open system is called a control surface. Every system has certain characteristics by which its physical condition may be described. Example: volume, temperature, pressure, etc. Such characteristics are called the properties of the system. When all the properties of the system have definite values, the system is said to exist in a definite state. Properties are the coordinates to describe the state of a system. Any operation in which one or more properties of a system change is called a change of state. When the path during a change of state is completely specified, the change of state is called a process. For example, a constant pressure process. A cycle is defined as a series of state changes such that the final state is identical with the initial state. Now, we all know that matter is made up of molecules and in turn of atoms. For example, 1 mm cube of air at standard temperature and pressure contains 10 to the power 16 molecules, each of which has a position and velocity. And these positions and velocities are generally not useful for determining how macroscopic systems will act. Hence, we neglect the fact that real matter is made up of atoms, and rather take it to be made up of continuous description of matter, where the properties of matter are considered as continuous function of space variables like volume, pressure, and temperature. This is the concept of continuum. Thermodynamic equilibrium is said to exist in a state when no change in any macroscopic property is seen when the system is isolated from its surroundings. There are three types of equilibrium that must be satisfied in order for a system to be in thermodynamic equilibrium. First, mechanical equilibrium, which translates to the absence of any unbalanced force within the system and also between the system and its surroundings. Second, chemical equilibrium, which requires no chemical reaction or matter transfer from one part of the system to another. And last, thermal equilibrium, which requires no spontaneous change in the property of the system if it is separated from the surroundings. When a body A is in thermal equilibrium with a body B and also separately with a body C, then B and C will be in thermal equilibrium with each other. This is the zeroth law of thermodynamics. It is the basis of temperature measurements, which is a distinct property of a thermodynamic system, which is measured using a thermometer, selecting a reference body, taking into account a certain property that changes with temperature. A common example is a mercury in glass thermometer, which uses length to indicate temperature. A closed system and its surroundings can interact in two ways. First, by work transfer, and second, by heat transfer, both of which are boundary phenomena. Heat and work are not properties of the system and hence cannot be stored by it. They are both path functions. That is, the magnitude of heat or work transfer depends upon the path that system follows during the change of state. Heat transfer is the energy transfer due to temperature difference only. All other energy transfers can be termed as work transfer. The first law of thermodynamics is essentially the law of conservation of energy. But since we need it in the terms of thermodynamics, it can be expressed under two forms. A. First law for a closed system undergoing a cycle, wherein the cyclic integral of the work done is always proportional to the cyclic integral of the heat transferred. The constant of proportionality is called the Joule's equivalent. B. First law for a closed system undergoing a change of state. When heat or work is done on a system resulting in change of state, the net energy transfer is stored in the system. This energy, termed as internal energy, is the difference between the work done and the heat rejected by the system. The major application of the first law of thermodynamics is to analyze the flow of mass across an open system, which is done by the classic steady flow energy equation. Here comes the end of quick revision of what thermodynamics is. Finally, it's time for this episode's question. What is a quasi-static process? Also, it's time to answer our last episode's question. How are glass tubes shaped? Molten glass is wrapped around a rotating hollow cylindrical mandrel and is drawn by a set of rolls. Air is blown through the mandrel to prevent the glass from collapsing.
So like, subscribe and comment with your feedback to help us make better videos. Thanks for watching.
In the next episode of Mechanical Engineering Insiders, find out what the second law of thermodynamics is.